goal of the UC6 prototype is to provide evidence of the broader applicability of the tools and techniques developed in the Pharma project. We wanted to demonstrate the integration of the runtime resource manager, runtime monitoring, dynamic memory management, design space exploration, and knock trace technology within the context of the project.
The prototype mimics a surveillance system where a set of reconfigurable applications are capable of changing some parameters in order to adapt themselves to runtime application requirements and available platform resources.
The prototype integrates 5 different technologies developed within the Pharma project. Specifically, it integrates the multi-view application, which is a stereo matching application for computing the distance of the moving objects within the scene, and 2 SVC decoders for decoding the input video stream and also reconfiguring the temporal and the quality layers of the scene according to the identified scenario.
First, we start the Barbecue Runtime Resource Manager, which initializes the multi-core platform into a host node for system processes and 1 or more device nodes where the applications will be deployed. This is the output of the prototype. In the left window, the decoded video captured by one of the stereo cameras shows the surveyed area. In the right window, we show the runtime configuration of the SVC decoders and multiview. At the beginning, nothing is happening in the scene, so the configuration ID of the SVC decoders is 0, which corresponds to the lowest SVC layer. This is why the quality of the output frame is poor. In the multiview configuration, you can see that the power saving mode is on, which means that multiview is disabled. Then we start the prototype, which will remain in the power saving configuration until any possible threat is detected in the scene. This is the case when a person enters the surveilled area, which triggers a reconfiguration of the system. Now the system is running in a mid-distance configuration since the detected object is moving away from the cameras. In this configuration, multiview ensures a response time less than 1 second, while providing a good quality of service, which means an accurate estimate of the distance. The long-distance configuration, when the object is far away from the cameras, brings the system back to the power-saving mode. Another person enters the area, so the system is reactivated. The previous person is approaching the cameras. When he gets over a distance threshold, then the highest configuration will be triggered. Now, you can see that the SVC decoders are decoding the highest layer, which corresponds to 15 frames per second, while before the frame rate was 7.5, and at the same time the quality of the output video is much better now. The time constraint on multiview is higher, so the application-specific monitor reduces the accuracy of the distance estimate to meet the frame rate goal, 2.5 frames per second. The goal is met since the measured frame rate is above the goal, which provides a response time less than 500 milliseconds. In this plot, we compare our prototype above with the baseline version that does not use the Barbecue Runtime Resource Manager below. The multiview runtime requirement, frame rate, depends on what is detected in the scene, so it should be the same since the input video used for the 2 implementations is the same. A first result is that our proposed prototype is more stable at runtime in following the frame rate goal. Besides that, the baseline version misses a possible threat in the scene, which is when the second person gets close to the cameras. Indeed, the frame rate goal is not increased to 2.5 frames per second as in our proposed prototype. This does not guarantee a good response time in the baseline version.